Hey everyone, this is the Kubeflow trainer call and also Katib call on 30th of May 2026. We're going to record this call and we're going to publish on YouTube. And as always, we follow the CNCF code of conduct. So I think today we have a few things to talk about around ongoing proposals in the agenda. So let's first of all maybe finalize the discussion around runtime snapshot. So just to give a heads up, I think we talked on this on the last call, how we want to move forward to give user a way to kind of like save the runtime it's been used for train job when the train job is triggered, and we end up with a solution that probably we want to use config map. So instead of using the CRD, you get a CRD or store the runtime um, inside the annotation or labels. We want to have just store this in a config map, so we have like construction format. So any other runtime like Slurm or like runtime which is not job set based will be also supported. I guess it's only one open question. Yeah, this is, I guess, how it looks like. So just a config map I have, which has an author reference to the train job, and it will create this config map when the train job is created, and the runtime just will be unstructured YAML, which is embedded in the runtime object. Only I think one open question: what we should do with the existing train job. I know I had this discussion with Europe. I think
Mm.
it's here, right? Um, yeah, like I guess so we have two solutions. So the one solution is to do nothing with existing train jobs and only create the runtime snapshot on the newly created jobs. Another solution is to also create the config map on already running jobs when the second reconciliation loop is triggered. Um, Want to hear your thoughts, like, and objections, what we should do here. Um,
Yeah, I mean, I think my feeling is that we don't really gain very much from having special behaviour for um, jobs that are running. I think the point that you made about the if we take a snapshot, it might not be the right snapshot. The runtime might have changed, so it might not actually be the snapshot that the train job was had when it first started. But
Yeah.
that's always going to be true. And if we have some special logic in for existing running train jobs, when are we okay to remove that logic? It is an extra complication that an extra sort of code path that we're going to have to maintain.
mhm. Yeah, I guess like we haven't really introduced the immutability to the API, right? So
Mm.
I kind of like try to understand what change will be less confusing for customers and for users, like especially if they have running jobs. If they see this config map appear, like do they really have any problems with that? And especially if the data will be, incorrectly set up there, right? Incorrectly configured there. Um, yeah, Vasilis?
I'm actually, is it even possible for the snapshot to be wrong? Because the CRD, the cluster training runtime, and the the namespace version of it, they're both immutable right now, right?
So not really, right? So we really didn't get a chance to introduce the mutability, right? I think Yuki has an open issue for this, and I think this PR is still in progress. Um,
Oh, so
yeah,
technically the objects are immutable right now?
it should be.
Sorry, are
Yeah,
mutable right
it's
now.
mutable. Yeah, it should be immutable. We just didn't get a chance to introduce immutability. I think it's if you, yeah, it's
Okay.
um,
Because, all right, so this defeats what I was gonna say.
yeah. So we kind of like have this open PR, but we've never get a chance to really merge it. Um, yeah, I think so. From my perspective, as part of like 2.3 release, we should kind of like introduces, mutability or immutability to the runtime, right? So at least we not really break API in the future. Um, yeah, I don't know. What do you think? Like from your perspective, like for this specific proposal, like what would be the kind of least, um, concerning change from user perspective?
So didn't we introduce runtime mutability check in our webhook? Not?
I don't think so. Let me see. I think there's an open issue, right, for immutability. Yeah, validation prevents. Yeah, I think this one. So this is what you created, I think, a year ago, right?
Uh, oh, I see.
So technically, our times are mutable right now. So
Yeah, technically, yes, but conceptually, we should allow users.
mhm. So what are your thoughts like for this specific proposal? Like, shall then in that case we only create the snapshot for the newly created jobs to ensure, like it has the correct data?
I think that depends on where which component do we want to create snapshot. I mean, so if webhook create or predicate create this snapshot, we so we can ignore running jobs. But if we implement reconciling mechanism for creating this snapshot, we should care about running jobs, right?
Yeah, but I guess like like in the reconciliation loop we will also fetch, we will pull the runtime, right? And I guess we will take this spec and create the snapshot from this spec, right? So for already running jobs. So I guess like if we decide to move forward with go ahead with for train jobs which are running during the upgrade, we also will create a snapshot that will require for us to do get on the training runtime, right? I guess like eventually we want to do this on the first train job creation, right? I guess this is a kind of additional flow, I guess, Rob, you want to implement, right? From my understanding. Um,
Yeah.
yeah.
Go
um,
ahead. No.
So I think my intention with this KEP was actually that we wouldn't need to have immutable runtimes at all anymore, because once a train job has been created, or when a train job is created, it will pick up the configuration of the runtime, and then it will never need to reference that runtime anymore. I
mhm.
appreciate this isn't answering your question, Andre, but I think this sort of maybe gets more to the root of like the motivation for this.
Okay. Yeah, I think it's fine. So yeah, what do you think? I mean, eventually, if you have a snapshot, we don't really need to have, this requirement so the runtimes must be immutable, right?
Yeah, that's my thinking.
Yeah,
Um,
I agree with you. So we shouldn't allow them to modify our runtimes. So we can assure the immutability on this runtime events.
So just to be clear, I'm thinking if we have this snapshot mechanism, then that issue that you just had open, Andre, we wouldn't actually need we wouldn't need the validation in the webhooks to prevent runtimes from
mm.
being mutated.
Yeah,
Yeah,
that's
yeah,
right.
yeah, yeah. That's right. That's right.
Okay, cool. Just checking that we're on the same page.
Yeah. So, Andrea, can you put mutability issue in this meeting notes or in this
Yeah.
cap? Yeah, I guess this is what we plan for mutability, and we want to support this one along with this snapshot mechanism.
So yeah, in that case, Silvio hands up. Like if we decide to go ahead with this cap allow us to make runtimes immutable, like, do we still want to, have this backward compatibility of already running train jobs? I just don't understand what is the reason for us to introduce additional logic to the controller. Is it just for upgrade? Like, what was your main motivation, Rob, like to have it for already running jobs?
So the main motivation is that uh, at the minute, if you say change the image in a runtime, um, that will get picked up in the train job reconciliation loop. And we have some logic in place to prevent the train job from actually picking up that new configuration. So job sets are immutable, so it's not going to change the actual running configuration. But the proposal here is about turning this into, rather than having code validation, turning this into part of the design contract that it is the running train job is completely independent of whatever changes are made to the runtime.
Yeah, but it'd still be problematic, right? Because the problem is if you apply this change for running train jobs, the snapshot might not represent the actual runtime which we used before the job was created, right? Like imagine like user creates the train job in the 2.2 release, like maybe a couple of months ago, right? And it's still running. And then over time, like, user, does some upgrade to the runtime. And then, the platform admins upgrade trainer to 2.3. So we're going to create this snapshot, which will pick up the image from the runtime, which is actually incorrect because the original train job has a different image, right? Does it make sense? Like, because like before this change, runtimes must be immutable. But since we didn't introduce this immutability, like, we can expect that users might upgrade the, already running jobs, already have, already created runtimes, right? That does make sense? Uh,
It 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 does make sense, but then let me see if I can phrase this. We You're right that the snapshot is going to be wrong, or may not actually reference what the runtime the train job is actually using. But the existing code that's in place means that the job set doesn't actually get updated, so it doesn't actually pick up this new configuration. And
yeah.
this is only actually going to happen to train jobs that were created before this change goes in.
Yeah.
I'm sort of looking at those as kind of legacy train jobs. Everything else after this is going to benefit from the train job being completely decoupled from the life cycle of the runtimes. And then this means that we can make whatever changes we want with the runtimes, including the bit that I had in the earlier in this proposal for removing the finalizers
Yeah.
for runtimes. It means that train job is entirely self-contained, and particularly the finalizers make help with sort of platform management of the operator. So we have things where if you uninstall your operator and then look to reinstall it quickly afterwards, but if you've got a train job running, you can get the control plane can be deleted before the train job is removed, and so the finalizer never gets removed, and you end up being unable to reinstall the operator. You get this finalizer stuck on the training runtimes. You can't reinstall them.
Yep, makes sense. Yeah, I see how you have hands up. Yeah, what is this?
I, I think that this change, the proposal by Robert, I don't think it makes the problem worse. I think it makes it slightly easier, or it eliminate. It's like what you brought up, the runtime changing, effectively the runtime changing after the job has started, right? That's a problem. This suggestion doesn't make it worse because the runtime is already inconsistent with whatever it is that was used to start the job set, right?
Yeah,
Because it
that's
has
right.
changed.
That's right.
However, this change, this proposal protects you against this specific scenario moving forward. Because
Okay.
if this is in place, then on first reconciliation, we will have the config map. And then from that point onwards, no matter what change you make to the runtime, they make no difference because this specific job is now tied to the config map.
Yeah, I understand. Yeah.
So it protects you against running into this problem. But if you've already run into this problem, it doesn't do anything, but it doesn't make it worse.
Okay. Okay. Yeah, I mean, I get this point. I mean, like, I understand, for the future production and if I just trying to understand if it really works to have this logic being in our controller. Like, what is the user benefit, right? Like, do we really see a user benefit to have this additional logic we just, only needed for this migration from 2.2 to 2.3, I guess, right? That's it. Like, um,
Yeah, I think that's my thing. So I think I'm aligned with you that we shouldn't have any special logic to migrate um, any existing train jobs because it's extra code that we have to maintain and at some point remove. But I think if we don't implement anything, existing train jobs will get automatically migrated and they will have a config map snapshot created for them because the reconcile loop that I'm proposing says, okay, look to see whether the snapshot exists. If the snapshot doesn't exist, take the current state of the runtime, copy it, and create the snapshot. So if we wanted special logic to not migrate existing train jobs, then we would have to say do something to say check whether the train job was, I don't know, created in a different version. To be honest, actually, I'm not entirely certain how we can do that.
I think you can do this just, in the first creation, right? In the builder. So we have this builder mechanism, right? So when you build the train job, so when initially the train job has been built, if it is firstly created, you can just, create a snapshot there. That's it. Like on upgrade, like you don't really do anything, right? It's only like on the first creation. Um, yeah, I think there is a way for you to figure out the first creation, the reconciliation loop, right? When the object's been created.
Is that reliable as part of the reconciliation loop? I'm thinking, do we have to look for a specific created event? I mean, what happens if the control plane is down and someone creates it, and then then the control plane is back up? Will we still get a hit that create event?
I see what you mean. Like basically, like what usually we do is or create on update, like right, and then if the controller is down, like we on the second reconciliation loop we create all those packages. I see what you mean. Yeah, Yuki, like what do you think on this? Like, would it make sense to just create it like it doesn't matter whether job was running before the upgrade or after upgrade, we always create the snapshot. That's it. If it doesn't exist.
Yeah, I honestly don't have strong opinion here. So after we introduce this config map based snapshot, I guess the desired state for the running train job, running train job runtime template is snapshotted config map instead of the training runtime custom resource, right? So I think the difference between snapshot and training runtime is just place for desired state, right? So I think so. No, I think there is no differences from user point of view.
Yeah, that makes sense. Yeah, I think it's fine. I mean, I think as Wesley's mentioned, like, it doesn't really matter, with this kind of protect user for additional, changes in the future. So even if the snapshot will be incorrectly set for running jobs, yes, we know this issue and we can report this issue, but for the future to create the jobs, I think we should be fine. So yeah, maybe I think it's definitely like it's something we should do because usually, yes, if the object is not exist, like we should probably recreate it, right? On every reconciliation loop.
Yeah, so if we face any use cases where we want to keep store the previous runtime informations, as we discussed in the previous committee meeting, so we might want to introduce revision mechanism for the snapshotting. But currently, we don't have any use cases for that. So we just introduce snapshotting the current training runtime, and we assume the snapshotted config map is for the is for the desired state in the current running train job.
Okay. I think this sounds fine for me. In that case, let's move forward with this proposal then, and we can definitely see what users say on the to the three. But I think it's definitely like the what we should do. Yes, and like I guess like Robin, maybe in the follow PR, let's update the cap to say like after this proposal, runtime is going to be mutable, right? So,
Yeah.
right.
Yeah.
Okay, should we move on quickly? Um, all right. So speaking about this, like, yeah, obviously, do you want to quickly give an overview where we are on the configurations?
Yes. Do you mind if I share the screen?
Yeah, sure.
Thank you. So hopefully you should be able to see this Google Doc, right?
Yep.
Okay, good. The idea is at a high level, we would like Kubeflow to enable some kind of an intelligence system that automatically sets the resource requirements of jobs. For example, the GPUs and things related to that. The crucial part is that it shouldn't be Kubeflow trainer itself that does this, because then if you want to, it's hard to have one super amazing way of setting the resource requirements that works for everything. I think it makes more sense if we allow people to basically bring in their own logic. Like you have, for instance, I've developed something that works for a specific, like the PyTorch API for fine-tuning models. So if you have something that works well with this controller that I made, you could potentially just hook my controller into your system, into your Kubeflow trainer environment, and it reads certain things in the command lines of your task and it decides with how many GPUs and which GPUs. Like you, okay, you need NVIDIA A100 for this thing, this many, right? What that means is there's two. First of all, does that make sense? Quick question number one. At a high level, we would like to be able to have a way to automatically set the resource requirements, and ideally, that way shouldn't be hard coded into trainer. Yes, Yuki.
So remember that you introduced this cap into the 2 months ago, 2 or 3 months ago committee meeting, and so I mentioned about so I'm worried about introducing no, not quarter resource suggestion mechanism, because so how to decouple from scheduling mechanism algorithm. I mean, so yeah, let's say so users users have Volcano, Unicorn, Q, or any kind of resource management system, and those resource scheduler have fair sharing and preemptions or whatever to make the cluster usage efficiently, right? And as far as I know, this resource automatically suggestion mechanism has a similar concept. In that case, how to mitigate the conflict between this resource suggestion mechanism and the scheduler side resource suggestion mechanism?
That's an excellent question because I think it drills into the actual core of this suggestion. The idea is, at least for the cap at this stage, we only do this once. We only mutate the job before we consider the job eligible for scheduling. So what that means, practically speaking, it's equivalent to the user before they create their job, just stopping and thinking for a few moments and saying, oh, you know what? I should request 24 GPUs, and that's it. So what I'm proposing here is instead of having the user spend some minutes thinking about the actual resource requirements they're going to submit for the job, there's this part here at the top where after the job is created and before it's considered for scheduling, actually before it's considered admissible for scheduling, because I want to tie this with Q. If you remember, I have recently I added a new way in Q where basically you can say gate the admission of this job until I tell you to, until I tell you this is admissible again. So imagine trainer asks Q to forget about a job while something else is reconfiguring it. And then once that something else is finished, from that point onwards, that job is just literally like any other job in the system. So your question is, okay, I have a system, I have Volcano, I have Q, I have other things in my environment which help apply fair share, which help apply quotas, right? So how will this thing interact with those systems? Those systems are down here. And the idea is, as long as we're careful, those systems will only see this new job once it has been finalized by something. So something has already decided how many GPUs to use. And at that point onwards, and only then is this job eligible for admission. So from the standpoint of Q, Volcano, Kubernetes in general, this is just a regular job that someone created with a specific resource requirement. Does that make sense?
So especially, so I want to emphasize about so fair sharing and preemptions, because high-level schedulers, Unicorn and Q, try to compute which workloads should be preempted based on the current cluster usage. This doesn't care about application point of view. So I'm worried about there's any confliction between this actual cluster usage balance and this application based resource suggestions. So the most worried part is, so after we introduce this suggestion mechanism, this this can reduce cluster usage, because currently high-level scheduler has their scheduler specific so I mean tune cluster capacity usage tuning algorithm and approach, right? And high-level scheduler don't have any information for this plugin mechanism, right? In that case, so high-level scheduler might preempt or fair share. I mean, so sorry. So so I mean, so high-level scheduler may preempt incorrect workloads by changing resource suggestions from this trainer controller mechanism. Because this trainer controller mechanism doesn't have any cluster capacity usage information and fair sharing algorithms, right? Just propose based on application specific
Can I give you
view.
one more detail? Sorry, and then I'll give you the word, Andre. Sorry. I think you have a very specific kind of plugin in mind. There's nothing stopping you from, and in fact, it's one of the user stories. There's nothing stopping this plugin from actually looking at the cluster state and saying, oh, you know what? There's like 25 jobs. There is Q installed here, and I can see that there's 16 things pending, and these are the resource requests of each of those things pending. So if I want to maximize the utilization of my cluster for this specific job, I should choose this many GPUs. But even so, my position is that this is orthogonal to systems like Q and Volcano. The reason being preemption. Let's pick preemption because you brought it up. When would preemption take place? I'm assuming we're talking about Q, so the preemption thing is switched on. Um, there's a new job coming in. Maybe it has a higher priority than those that are already executing. And so Q says, oh, actually, I should get rid of job 24 so that I make room for this new job, right? That's the scenario you're envisioning. Is that correct?
Yeah, so in case of flat cluster structure, flat team structure, it's fine. But in practical scheduler, they consider about hierarchical team usage and cluster usage and multi-cluster usage for preemptions.
Mhm.
In that case, how to care about that in this trainer mechanism?
What I'm proposing is that this will not make a difference because um, this mutation will only happen once, shortly after the job has been created, and only for the jobs that opt in, if that makes sense. So 15 seconds after this thing has been created, and before we allow any part, before we allow Q to consider this as an admissible job, the uh, that's what am I trying to say? Sorry, I'm a bit tired. I apologize.
Yeah. No
So
worries.
after the job has been created, before it's considered by Q as an admissible workload, we will change the resources once, and then we will never touch it again. So let's say for like roughly 1 second, 15 seconds, however long the plugin takes to update the job, this is like a special job, and Q will not schedule it, it will not consider it, it will not even reserve quota for it, right? So there is no way of doing preemption on behalf of this specific job for like 5-10 seconds, and then immediately after that, it's just a regular job which just happens to have the resource requirements that an intelligent system decided instead of a human. What I'm proposing is that this is orthogonal, and in fact, it might help with your use case. Sorry, it might help address the scenario you have in mind if the plugin this job is using has been optimized to increase the utilization of the cluster. Because it's harder for a human to take all of those things into account dynamically when they create the job compared to having a system that is purpose built for making these kind of decisions. And sorry, I think Andre, you want to say
Yeah, sorry,
something.
like I guess there are two things, right? So Q should work very well with external schedulers, right? I think we discussed this for many times before, and I just was looking at obviously your PR was also merged to Q. So I guess the like admission gated by mechanism could help us to tell Q, hey, don't touch this job. This job is still kind of like on the on the submission stage. Only try to apply your fair sharing or other algorithms when the job is ready to be admitted. I think it's similar to Yuki, if you remember, like in hyperparameter tuning, for example, right? We do have also another schedulers who will decide, you know, which like how many trials should be created, right? Or even other algorithms which can also like decide, when where the job needs to be submitted on the cluster. So Q should kind of like work well with those external schedulers here. And I guess from my understanding, if we use this capability with admission by, that should help us to tell Q, don't touch this job until we tell you it has the correct spec, right? And the GPUs is part of the spec. That does make sense to you?
Yeah, so that's correct for the admission gated by mechanism. So what I mean is, so I mean this trainer resource suggestion mechanism might propose correct proposal only for this job, only for this job. But from the cluster usage point of view, this might not better, right? Because if this trainer want to decide the best resource, cluster entire cluster usage point of view,
Mhm.
this trainer job correct all cluster usage and all capacity fair usage, right?
So
But
yeah, so sorry, finish your point. Good.
yeah, but as I check this proposal, it doesn't have any mechanism to correct cluster capacity, right?
Yeah, so from my understanding, those plugins, they're not really, take into consideration the cluster aspect, right? They only focus on your application, right? It checks the application and understand, how many GPUs you need for this application. Like I understand, like from the application perspective, it is better to have like more than less, right? So we need to probably talk about this, like if you have more GPUs, how you tell your plugin, hey, you can use up to this amount of GPUs, right? But from my understanding, like this, you only take into consideration the application logic here, right? Not the cluster capacity.
Yes, and only for incoming the exactly one trade job, right?
Yes, yes.
This plugin doesn't care
Not
about
necessarily is the answer.
Okay.
The answer is not necessarily. I think that that's the problem. This is the problem that I face with this cap. I think people have a very specific plugin in their mind, which is why I try to write this comment here. I'm not sure if it's visible on the screen. Oh my God, please stop moving. Uh, Basically, every single thing that is related to generating the resource requirements for a job, anything you can think of, looking at the cluster, looking at the job definition, looking at the sky, sending a request to an LLM, anything, all of those things, they go into the plugin. So if you have the value of this feature is tied to how good the plugin you're using or how optimized it is for the specific use case that you have in mind. So for example, Yuki, there is a way where the plugin literally does everything you hope for it to do. Like look at this specific cluster that you're about to run on. Look at all the connected multi-queue clusters that are associated with this specific cluster queue. Look at those states and then decide the best appropriate resource requirements for the job you're about to submit or the job you just submitted. This is a plugin someone could implement. However, the protocol here is extremely simple so that the barrier of entry, like if a random person wants to implement a plugin for their own cluster, they don't have to follow a gazillion rules in order to try it out, if you will. So what I try to write here in this cap is I try to partition it into two parts. Anything that's related to coming up with the numbers about the resource requirements, I put that into a black box and I say this is the responsibility of the plugin developer. Okay, so then what does trainer do? Trainer is the enabler for the whole thing, is the thing that talks the protocol. So as a user who's implementing a plugin, I shouldn't have to worry about talking with Q. I will let trainer do it on my behalf. The only thing that I worry about is somehow generating a resource requirement that is good enough for my use case, for the use case that I optimized my plugin for. And then the things that trainer has to do is basically those things in yellow here. Get the job so that this also works in an environment where Q is installed. This is all of the magic box, sorry, the black box business that happens inside the plugin. And then that's after the plugin has decided the resource requirements and somehow communicated that to trainer, and that's an open question in a way. Trainer then does the remaining parts, which is some kind of a guardrail. Like for example, you can say, as a system administrator, as a platform administrator, I don't want any of my jobs to request more than X GPUs. For example, this could be a guardrail you set at the level of my job, at the level of the job, and then Kubeflow makes sure that if the plugin suggesting something that's irrelevant, sorry, something that violates those guardrails, then we have some kind of a recovery strategy. So this is all part of the guardrail thing. The second thing you need is observability. Once you have those external controllers mutating the resources of your job and potentially other fields, and I will come to that later, you definitely need a way to understand why your job changed, right? And that's the purpose of trainer, because trainer can see exactly, trainer owns the API that these controllers will use to suggest changes, and thus it knows exactly which changes they made. And that will drive observability, both with status updates and events, or rather probably a combination of those things. And then finally, once trainer has applied the guardrails and ensured that the changes the plugin is requesting are valid, whatever valid means, then it ungates the job and leaves it travel through the system the way it was supposed to do in the first place. But like, do you see this separation, if you will? Does that make sense?
So let me clarify my position. So actually, I fully understand. So your motivation is buried stories in ML platform. The point is whether or not we should implement these mechanisms in the trainer side. Because as you said, so this open the box to implement anything, any scheduling, any resource suggestions, anything, right? But we trainer is currently focusing on machine learning application configurations, right? After these implementations, we support also scheduling mechanism, right? So again, so the whether or not we should implement this in training job site. And so as I check this proposal, the primary supporting target is Q, right? I guess so gating admission mechanism is only for Q, right? And so any other unicorn and broken doesn't have such mechanism. In that case, why not you want to implement custom suggestion controllers separate from trainers for Q?
Yeah, I guess the things like we do support other schedulers like, call scheduling or Volcano today in Podgroup policy API. So this proposal won't really, it's not going to work for them, right? Because they don't have this capability of, gated, getting the job.
Yeah, and so we typically just delegate such scheduling mechanism to the external scheduler, call scheduler, Vulkan, Kai, Q, right? But this try to implement such scheduling by ourselves in trainer side. Go ahead, Rob.
I don't want to sort of pivot the conversation too much, but I think I understand the value and the aim of this feature, and I think it would be. I can certainly see the value of alleviating the users from having to work out things like the size of their jobs based on the current cluster state. I've done similar things in previous projects, and I know that they can be really tricky to get right. And I think I'm struggling to see is this something where you have sort of a proven sort of example plugin, and we sort of have proven value for this, because I think that might help unlock if we can prove the value of the feature. It might help unlock the conversation about how we go about implementing this. So specifically, what I'm wondering is, we could this feature I think could be implemented as a sort of a client side, custom library that makes the necessary calls to KFT. Maybe it creates a few test jobs to see how the deployment might look. It might look at what's available in the cluster, and then make the suggested train job manifest and submit that into the cluster. We could do that in a way that doesn't actually make any changes to the train job or Kubeflow trainer itself. I'm wondering, have you explored that at all? That might help provide a sort of concrete sort of grounding for how we should do this.
You're absolutely correct. You can do this without making any changes to trainer, and that's what I've done. So I have a prototype operator of sorts, which it doesn't work with trainer jobs. It works with PyTorch jobs, primarily because that's what I had at the time when I was working with it. And also, PyTorch jobs are a bit special. They allow you to modify the resources. Actually, you can modify the entire thing, except for when you're using Q as your manager. You're not allowed to change oh my God, the cluster queue. You're sorry, the local queue. You cannot change the local queue. Anything else you can change. So I have it's actually open source. I have a controller where I've tied it to, I wrote this plugin. I'm using the terminology of this kit. I wrote a plugin which works for a thing that we use in IBM research, which is called FMS HF tuning, which is basically a wrapper over the SFT trainer API from Hugging Face. And what I did to create this plugin, I wrote a whole other framework and I did extensive profiling on fine-tuning jobs, about 12,000 jobs with different, options like different tuning methods, different GPUs, different batch size, blah, 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 and different models. So I built a huge data set, and then one of my colleagues, he created a model which predicts the best resources for a given job. And then I wrap that into a controller. And then I just have my controller that works with Python shop. That was when I made the change to Q because I was testing this on an environment that is Q managed. And I needed a way to ask Q to hold off admitting my jobs before I'm done patching them, because I didn't want to run into the problems that Yuki was saying, preempting other jobs for no reason. And so I have a proof of concept that works. But then when I was talking with people in issues on Q and trainer, it seemed like there's a need for this kind of approach in trainer, so that as a user that's implementing this feature or using this feature, you don't have to worry about things that are happening in the platform layer. Like all of those things that I did with Q, I've already done them. Why have the developer of the plugin worry about that stuff? Because it's like I know how to fix them. I've already done it before. I literally implement this, so I know what the process looks like. Why not have this protocol inside Trainer? And then for a specific use case, which is train jobs, so not everything that Q can handle, but only one of them, only one of the workload types, I guess. Let's call them workload types. We can have a standard for automatically setting the resource requirements. And if the catches on, perfect.
Yeah.
Maybe we can find a different environment to add this thing.
Sorry, like I guess the problem we try to solve is to give user a way to submit train job without setting resources per node. This is like the goal, right? Like allowing users to create the jobs without in the Kubernetes there is no way. I mean, you can submit pods without resources will be best effort, but Q like you can like point me if I'm wrong, but in Q for any other type of jobs, user has to specify resources, right? Container resources to submit those CRs.
Yeah, correct.
Yeah,
Yeah,
so
but it's not a must-have. So even if you don't specify resource requirement, yeah, we queue strongly recommend to specify that, but it's not must-have.
But if user doesn't specify the resources, it will be best effort, right? So Q, because Q
Yeah,
doesn't know about, okay. Yeah, this is like the problem we try to solve here. Like how we can allow users to submit train jobs without asking them to set the container resources. Does it make sense in terms of, like the goal we try to solve, like the problem we try to solve here?
yeah. So again, I fully understand this story,
Yeah.
and it's very useful. I just wondering. So opening this box indicates we allow all platform developers to implement everything functionalities. I just worried about this. This might make chaos in the ML classes because the all plugin developers doesn't know the details of this mechanism. They just implement a plugin based on the interface, right? So they might implement not 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 better plugin like to scrape cluster usage, to scrape quota usage, to scrape whatever. How to prevent that? I guess there is no way to prevent that because so implementing everything, every use cases is the most advantage for this mechanism, right?
Yep.
I-
Yeah, I mean, yeah.
So yeah, so in that case, so how to make guardrail to prevent such no better bragging.
I have a
Yeah,
question for you.
yeah, go ahead.
It's similar to what I said earlier about Rob's proposal. I don't think this cap makes it worse. I think it makes it slightly better. Because today, like I told you, I've already done this before without changing trainer at all. So if I want to, if a person wants to create a bad plugin, there is a way to do it. Literally, you just have I'll tell you how. You fire a webhook, you stop the at the time that an object is created, you just mutate it. There's Kubeflow can do nothing. It's like there's nothing you can do. Or you can have a protocol where a user creates a job which is malformed so that it doesn't go through. For example, it uses a fake queue name, which is what I did. And then there's another controller which doesn't patch that job, it just creates a new one. That's better. So there's nothing stopping users from creating bad plugins. What we can do on the trainer side is we can start with some basic guardrails. And here I'm suggesting, I have suggestions here, which are mostly focus on like applying quotas. But in future iterations of this thing, you can imagine like if we come up with a way to judge to grade, let's say grade the suggestion that the controller is making, we can see, oh, you know what, this thing has been consistently messing up my cursor, so I'm gonna disable it. You see where I'm going? Like, I don't think this makes things worse. I think it gives you a tool, and if you use it well, you make your platform player better, more intelligent. If you use it poorly, yes, you can make some damage, or you can have some underutilization of your hardware. And sorry, Andre, you want to say something? I burst in. I
No, no, sorry.
apologize.
Sorry. Like, I guess I know we're over time, but I guess thinking about guardrails is important. I guess I agree with you, Yuki. Like, platform admins can definitely mess up with the cluster if they build a bad plugin. I mean, you're absolutely right here. I don't know if you really need to prevent it, right? But I mean, like, we as the open source community can, give you some sort of reference architecture for, I don't know, for example, if you use Q and if you use PyTorch, we give you like a reference plugin how you can, optimally set up the GPU configuration, right? Based on the historical data and other knowledge we know about those resources. Um, I guess my point is here, it's like Q already works with external scalars, like for example, Ray, right? So Ray has its own scalar within Ray cluster concept. And Q knows how to orchestrate Ray clusters, right? Um, I'm trying to like understand from your perspective, do you see kind of like a major concern to open a way for users to build those plugins? So, we use this admission by feature to, like to set the automatically resources, and we have a way to opt in or opt out from this capability. Do you see kind of a strong concern to, not allowing to do so in trainer?
So I believe open source community provided plugin works perfectly. They just provide resource suggestions. Again, so um, I just worried about opening this box. Um, so I mean, so I actually don't have exactly example because opening box indicates allowing everything, right?
Hmm. Okay.
So if we can mitigate this opening box problems, it's okay. But so we should um care about the guardrail and limitations to prevent that as much as possible when we introduce this plugin mechanism.
All right. So what should be the next steps here, you think? Like, shall we like try to think, what is how we can maybe have some sort of POC or a way to, like showcase the plugin but not give away for user to register any plugins. So we just at least prototype and see how this will work together. So for the first initial version, we're not going to build the protocol, but we just build one of the plugin we can use, and then at least see the prototype here.
Yeah, I think the next step is defining interface
Okay.
and create a single at least one example plugin.
Hmm.
And so I just wondering if this will only this is only for Q because so this diagram mention about gate admission mechanism. So in case of so I mean when platform admin don't install Q into their clusters, will this work perfectly or not?
I think so. The reason being, um, there's two gates here. One is the admission gate. The other is Kubeflow trainer itself has a way to gate the job set objects it's creating. It can just suspend them, right? Now, the integration with Q is exactly for the scenario you brought up. We don't want to have false use preemptions, and I know I'm taking time. I'll be super brief. On top of that, in order to ensure, oh my God, consistency with Kubernetes itself, we will have trainer actually gate the job objects it creates, the job set objects it creates. So this solution will work in both Q managed namespaces and also Kubernetes like vanilla namespaces. And in the event that there's other frameworks running on the same like performing similar things to Q that are managing that namespace, trainer will ensure that the job set will not be active before this plugin has finished touching it, if that makes sense.
So I guess we can identify uh, if the train job is managed by Q name label, right? So I guess trainer just detect Q name label in the train job, and it has the label. We add admission gated by labels to the train job and adjust resource requirements. Otherwise, trainer controller doesn't insert such admission gated by labels and just suspend train job to prevent from automatically creating a job set, right?
Yes.
In that case, do we need to assume other scenario? I mean, so yeah, so currently, so vanilla cluster and Q installed cluster work perfectly. However, so in case of other scheduler, how to detect, I mean, so I'm not familiar with other scheduler mechanism, but I just wondering if we should add any kind of uh, train job level API to specify uh, if this train job is managed by another or other scheduler. I mean, let's say so if user specify volcano labels to the train job care about volcano mechanism and mutate the volcano specific labels to the train job or whatever. Do we need to have such mechanism? I am just asking to you so whether or not we should have dedicated APIs to represent that. Yeah, for
My
sure. So
only
we don't yeah, we don't have enough time at this time. So yeah, so before the next
maybe we can take it
committee
in the
meeting.
comment section. Maybe we can take it in the
Yeah, yeah,
comment
yeah,
section,
yeah, yeah.
Katib.
Before the next committee meeting. So can you post uh
I also like a couple
comment?
of, yeah, proposals for job returns gate. Maybe like I know obviously you've been aware of them, but maybe we can also take a look to see, how community is going towards this readiness, right? I know that, for example, like, agents and box projects, they also like discussion on, have a discussion on suspend and resume. So maybe we can learn something from them as well. I will link them in the meeting notes. Yeah, so let's definitely have a follow-up here. I think, yeah, is there good?
No, no, yes, please. Sorry, go
Yeah,
on.
I just want to say, like, just want to get like a little of your time, but let's definitely, have a, some sort of, initial POC in the interface, and maybe a way how we can, have this at least one plugin being in place, and then, figure out where you want to be queue specific, or as you can mention, like how we can deal with other schedulers, that we will actually support, right? And what if, like users today, they leveraging those capabilities, right? And I will link those PRs in the meeting notes as well. So let's see on this. Right. So I know we like over time. So any other questions, comments? Um, right. Great work. Anyway, I guess, like, we should definitely have at least something here to follow up. And again, having a way for user to submit the jobs without worrying about GPU resources is important. I guess we just need to find a way how to do this right. Because, like, we also see a lot of issues when customers just don't really understand how many GPUs they always want as much as as we have, but at the same time, maybe it's not as optimal, as they need, right, to run their job. So it's definitely something, many users would love to have. Um, right, great discussion, guys. Thank you so much for your time. I appreciate staying over time. So see you
Thank you.
soon. Yeah, thanks everyone. Speak to you soon.
Merci.